Hello guys, welcome back to Math from my desk, and in today's video, we will be proven that the derivative with respect to x of the natural log of x is equal to 1 over x. So let's go ahead and do that. So the way we'll be doing that is by using the first principle, aka the limit definition. So we know that the limit definition of the derivative, so we have a function f of x, and we want to find this derivative f prime of x. That's going to equal the limit as h approaches 0 of f of x plus h minus f of x all over h. And so our function in this case, our f of x, is the natural log of x. So what that means is, let me first just define f of x as equal to the natural log of x right here. So f prime of x in our case is going to equal the limit as h approaches 0 of the natural log of x plus h minus the natural log of x divided by h. And so essentially what we're going to be doing is we're going to go ahead and solve for this. So we know from limits properties that if we, logarithm properties, that if we have something, let's say log of a minus log of b, this is also equal to log of a divided by b. So this is one of the core logarithmic properties that are learned or are taught in pre-calc. So this is what we're going to go ahead and use for the numerator. So we write this as f prime of x is equal to the limit as h goes to 0 of the natural log of x plus h divided by x, and we have all of that divided by h. And what I'm going to do now is I'm going to rewrite this to get 1 over h here. So I have f prime of x is equal to the limit as h approaches 0 of 1 over h times the natural log of x plus h divided by x, which actually I'm just going to go ahead and rewrite that as 1 plus h over x. And why is that? It's because x over x is 1 and h over x is simply h over x. So this is what we have for now. Then now what we're going to do is we're going to recall a logarithmic property that says if we have something, let's say a times the log of b, this right here is equal to the log of b to the a. And so we're going to go ahead and use that property right here with 1 over h. We're going to go ahead and put that in our exponent. So we have f prime of x is equal to the limit as h approaches 0 of the natural log of 1 plus h over x to the power of 1 over h. And now what I'm going to do is really interesting. I'm going to use variables, and I'm going to go ahead and manipulate those variables to get a result. So I'm going to take this h over x, and I'm going to define that as, let's say, m. So we have m is equal to h over x. And I can rewrite this to solve for h, and I get h is equal to mx. Now what I'm going to do is I'm going to replace these over here. So I rewrite this f prime of x is equal to the limit as, now is not going to be h as h approaches 0. So we're going to want m over here. Now as h approaches 0, we need to decide what m approaches. So if we look at this function here, as h goes to 0, m looks like it's also going to go to 0, since the numerator is going to be 0, and 0 divided by anything that's non-zero will be 0. So we have the limit as m goes to 0 is equal to, the limit as m approaches 0 of the natural log of 1 plus m to the power of 1 over h, where h is mx. So we have 1 over m times 1 over x. Now what I'm going to do is I'm going to use this same property right here, and instead of going from this to this, I'm going to go from this to this. So I'm going to take this 1 over x and bring it right here. So what I have is f prime of x is equal to the limit as m approaches 0 of 1 over x times the natural log of 1 plus m to the 1 over m. And I'm going to go ahead and take a new paper for this. But first, let me explain what I'm going to do next. Now, what I'm going to do is, since this limit is in terms of m, as we have m approaches 0, we can sort of treat 1 over x as a constant. So I can go ahead and take that out of the limit. So that's what I'm going to do right now. So we have f prime of x is equal to 1 over x times the limit as, m goes to 0 of the natural log of 1 plus m to the 1 over m. Now what I'm going to do is, this looks a lot like a certain limit that we want to evaluate. So now what I'm going to do is I'm going to go ahead and I'm talking about this part, 1 plus m times 1 over m. And we're going to go ahead and find out what this limit is very soon. So right here, if I let's say n equal 1, that doesn't look like an n. N equals 1 over m. Then that means that m is equal to 1 over n. And first, quickly, we're going to recall that E, Euler's number, which is 2.7-ish, a little, well, obviously it's irrational, so it goes on forever. E is equal to the limit as n goes to infinity of 1 plus 1 over n to the n. And so if we get to this result right here, we're going to be able to get the natural log of E, and the natural log of E is 1, so we're going to end up with 1 over x as we take the limit here. So this is what we're trying to get here. So we rewrite this as f prime of x is equal to 1 over x times the limit. Now we want to put this as a limit as n goes to some value. So as m here goes to 0, so as this goes to 0, it appears that n will go to infinity because we're going to get closer to 1 over 0, which gives us an asymptote. 1 over 0, of course, itself is undefined. However, it is asymptotic around 0. So it's going to be the limit as n goes to infinity of the natural log of 1 plus, in this case, we defined m to be 1 over n to the power of 1 over m, which we defined as n. Now we recognize that 1 plus 1 over n to the n is simply E. It's simply Euler's number. So we end up with f prime of x is equal to 1 over x times the limit as h goes to infinity, or sorry, that's n, not h, as n goes to infinity of the natural log of E, Euler's number. By the way, here there isn't a limit as n goes to infinity. However, you will simply be able to define this 1 plus 1 over n to the n as E, because the n goes to infinity is right here. So like this fits. Because if you think about it, I don't have a calculator near me, but if you use bigger and bigger n values, this will go to approximately 2.7-ish. So this step right here is correct. Then the natural log of E, that is simply equal to 1. So this right here is 1. So what we end up with is f prime of x is equal to 1 over x times the limit as n goes to infinity of 1, which is simply 1. So f prime of x is equal to 1 over x. This right here is our answer, and this is for the function f of x is equal to the natural log of x. And this right here is the sort of, this is how we derive that the derivative of the natural log of x is 1 over x, the derivative with respect to x. I hope you guys enjoyed this video. Don't forget to subscribe, and I'll see you guys soon for another video.